Hello, today I'm going to be modeling one of the higher order mode couplers that I found in this paper. So I made a video earlier on about the Tesla type higher order mode coupler and just gave a brief description of what higher order mode couplers, um, the role they perform in accelerating cavity design. So this video will just be um, modeling a different kind of higher order mode coupler. I mean, they perform the same purpose but then different shape. So going through this paper, comparison of coaxial higher order mode couplers for CERN superconducting proton Linac study SPL, and yeah, by Kai Papke. Really interesting paper. So here you can already see some kind of complicated geometries. I think yeah, I mean, if you want to see the Tesla type coupler, you could check the video. I would link the video also maybe to this video or in the description somewhere. So I'm just going to scroll down. Yes, now to the different types of coupler that was couplers, high order mode couplers that were compared in this study. So we have the probe type coupler with this shape. We have the probe version 2, which is kind of a different shape. You have a second notch here. Okay, I haven't described what a notch is, but I will in a short while. So then we have the probe version 3, and then you also have the hook type, and oh, of course, the Tesla type coupler that we modeled the last time is also here. So I think you can go through the paper to see the relevant information, but then the coupler I'm going to be modeling today is the hook type coupler with a double notch. So this actually gives a double notch. And then what do I mean by a notch? Now if I think I should go to a comparison plot of the transmission properties. I don't have a normal. Okay, now I think I mentioned in the last video that the coupler, the higher order mode coupler, actually is designed to perform two primary purposes. So the first one is the extraction of parasitic modes that may be dangerous to beam dynamics, or also reduce the efficiency of the accelerating cavity. Now the second purpose is to reject the fundamental mode frequency. So the frequency, the excitation frequency that we want to use for the acceleration of the particles. So we don't want, because I think I could also show it here, so much moving back and forth. So what happens is that we feed in energy at a particular frequency, which is the fundamental mode frequency, through the fundamental power coupler. And what we don't want is that a higher order mode, which is an antenna, to extract also this energy, because then this would, reduce the efficiency of the accelerating cavity. So we want a strong rejection of the fundamental mode, and that is one of the design goals of the higher order mode coupler. So I think the coupler that was used here operates at, it should be about maybe 5, so this should be 7.5, so maybe about 500 and something megahertz. I don't know if I can find that here. Okay, yeah, I think 704 megahertz. 704 megahertz, that's the fundamental frequency. So you see a sharp notch at this point. So this is the rejection of the fundamental mode at this particular frequency, 704. Now you see just one notch here for the Tesla type cavity and the hook type version 1, which has the hook type V1, which has just one of these, just one notch, which is this here. Oh, sorry. What is responsible for the first notch is this, so it has just this, and then what is responsible for the second notch is this piece of conductor that is here. So for the hook type, I think I'm scrolling too fast, but you could always look at the paper and go through it. So we have just one notch, but then for the higher order mode couplers with a second, now going back up again, I think I can use this one with a second conductor. Okay, it's even written here, secondary notch. With a secondary notch has these properties, that it has a kind of second notch at this point. Now, how is this useful for us? You see that you have a kind of very small bandwidth for the rejection. So any slight change in the properties of in the geometry of the higher order mode coupler may lead to a shift in this notch, and then you have like really drastic um, um, not improvement, deterioration of the rejection properties of the coupler. But then when you have a larger bandwidth, you see that this is what the second notch affords you. You have a larger bandwidth, so it's not very sensitive. I mean, that's the term. So for these hook type couplers, they are very sensitive to the geometric properties. The notch, the notch frequency, it's very sensitive to the geometric properties. But then you see that if we should have a second notch, then you have a larger bandwidth, so it is not as sensitive as the notch as the regular hook type coupler. So yeah, just I said brief introduction, but I guess I've spent a lot of time. So this is what I'll be modeling today. I mean, not exactly, because I'll be adding maybe or removing some things from experience. So the first thing I usually do is I create, where's that? I create kind of a model so that I see, okay, don't mind this, this is the wrong image for this. Forgot to remove that. So this is the regular hook type coupler. I don't think I've made a video about this. Okay, I don't think I have. Maybe I'll do it in a later video. So first thing I like to do is to kind of do a 2D sketch of my coupler, and so that I can determine beforehand the variables that I need and name them appropriately, and try to name them in a logical order. So because yeah, there are lots of variables, and then you could kind of get lost in the naming and everything. So I name all the lengths L. So the lengths L, so L1, L2 from bottom to top, and then yeah, so I just have my own naming convention. You could also use your naming convention, and P stands for penetration, which is the yeah, how much the coupler gets into the beam pipe. And then you have, yeah, so basically I just make something like this that would guide me throughout the modeling process. I don't know how I can make this image available. I think maybe you can just make a screenshot of it, because yeah, I don't think I can. I don't know where to upload it to, but yeah, I think you can just make a screenshot and see. Wait, let me make it bigger. And yes, so now it contains all the variables that are required, I hope. But then if there's any variable that I didn't include, yeah, I could always include it. Yeah, so can go ahead and make a screenshot as a guide, because I'm going to be moving this away from the screen, so I have the whole area for CST. Now I have the image on another screen, so I'll be making reference to it. And yes, let's get modeling. So yeah, first thing, you go to open your CST Studio 3D simulation high frequency, and then you have this. We're not really concerned about the setup solver for now, but I'll just change it to frequency domain solver. That's what we want to solve. And then I change the units to megahertz. You could also leave it in gigahertz. I just prefer working in megahertz. So, and length in millimeter, that's okay. Now let's start modeling. Okay, first of all, I could go ahead and save it. Where should I save this? I think I could just save it here. Hook coupler double notch. Okay, and I think with that we are ready. So okay, I think I would have to be moving this top on. So the way I like to start, the way I like to model the hook coupler is to start from the bottom and model up. So first of all, I create the beam pipe, and then move up to create the chamber containing the poles. Then from there, I go from top to bottom. So let's see. So first of all, I think instead of making up values for the variables, I'll just, because I've modeled this before, so I'll just go ahead and yes, so this is the model I had initially. I'll just go ahead and save the parameters to a file and then load it, so I don't have to make up. I think for the Tesla type cavity, I made up variables, variable values as well. So I'm going to save this to let me save it here. So I'll save it as hook, coupler, double notch, and save it as text. No. Coupler, double notch, and then .txt. Yes. So I think I'll just leave this open in case I run into some problem. So I could always refer back to it, or maybe also copy some variables, or maybe I could just I'll just start this. So now to load parameters, so you have your parameters list. We have nothing currently. Now what I did just now, I don't think I've showed this before, is save a parameter list set to a file. So how you do this is to right click and then you see save parameters to file. So you can save whatever parameters to the file and then upload it to a different model. So now I have my parameter list. Make sure it's not in result navigator but in parameter list, and then right click and go to load parameters from file. So I'm going to navigate over to the file I saved, which is hook, coupler, double notch, and then load it. So I have all the parameters that I need, and yes, start modeling. So RIS stands for the beam pipe radius. So, and the beam pipe is just just a cylinder. So I go to my modeling tab and then click on cylinder, and then I click on escape. So I want to model it so that it's centered around the working plane. So I could click on 6. So I want it to be centered around the working plane, so it would have something like this. So now for the outer radius, I go ahead and type in RI, inner radius none, and orientation is Z. So no changes. And then now for the Z max, now I have to bring up this again. Okay, now for the Z max, I want that so this is kind of the top view. So I want the Z max to be the radius, not the diameter of this, which is this chamber, then plus a kind of offset which I call CO. So kind of the offset of the beam pipe from the chamber wall. So I call that CO. So I'm going to be, and then CO is just on one side, so I have CO on the other side too. So cavity offset, I think that's the reason for the CO. So Z min. Now remember, I'm dealing with diameter, so, and I want to centralize it, so I'm going to be doing minus dch, which is d chamber, divided by 2, then minus co, which is the offset, then this one is dch divided by 2, and I'm using divided by 2 because it will be radius on both sides, so plus co. Now I go ahead and preview this, and very big. So this is what I have, and then change the material to vacuum. Yes, and yes, there we have it, the beam pipe. Now I'm going to click on 3 to view it from the front, and then now going over to model the chamber. So first of all, we have this, which is a cylinder, and then this other one, which is a cylinder. So this cylinder, I'm going to make it go from 0 to, it's not going to matter if it goes from here or whatsoever. Once I combine everything together, then it's going to be one solid. So I'm going to make it go from 0 to, now the height of this would be Ri, then dh divided by 2, which is the radius from here to here. I don't know if I can annotate this thing, I doubt. So from this point to this point would be half of dh, which is the radius. But then we have a penetration, so I have to subtract the penetration. So it's going to be Ri plus dh over 2 plus the penetration to give the height from 0 to this level. Then the rest is just easy. It's just addition of length. So plus L1, L2, L23, then C23, C23, L3. Yeah, lots of there's another C23 here, so double C23, and then L3 and C34, L4. Yes, that gets us up to this point, so that's what I'll be doing. I don't know if I should copy it somewhere. I'll just type it. So cylinder, escape, and then first thing you have to do is to change the orientation to Y. So want the cylinder to be standing, not lying on its surface. So the outer radius is dch divided by 2, and yeah, no inner radius, and the x center is 0, z center is also 0, and then what we want is the y max to be Ri plus dh over 2 minus p, which is what I showed, then plus L1 plus L2 plus L23, yes, plus C23, yes, plus T23 plus C23 plus L3. Okay, plus L4. Hopefully that's it. So now we can go ahead and preview. So yes, this is what we have, and if I should click on 6, I go to the side view, and 3, I go to the front view. So we have the first cylinder that makes up the chamber, and I could click OK. Hopefully everything is correct. Now before I click OK, I go ahead and copy the variables, the y max here, because I'm going to be building on top of it, and then when I'm modeling the antenna itself, then I'm going to be removing some of all these variables. So I'm going to Control A to select all, and Control C. So Control C on this to copy, and then OK. Now none to all, so I'm not merging anything. So this is what I have. Now I'm going to turn off the working axis. Yes. So the next, we build the next cylinder on top. Okay, I think I should find a way to. So we're building the cylinder on top. Now 3, and yes, so modeling cylinder, orientation Y, radius would be, what's the radius of this? It's d5, yes, d5 divided by 2, and then y minimum would be, now I want y minimum to be this top point that we had initially, and then y maximum would now be plus L5. So we have that we are making a cylinder from this level to this level, so the length of this is just L5. Now preview, and yep, correct position. So okay, now we are done with the, oh, I forgot to copy the maximum variable, but then it's just plus L5, so it's no big deal. So we have the chamber all modeled, 3. Now building the antenna itself, so we are going to work top to bottom, and yeah, the antenna is just cylindrical, so we are going to be using a lot of cylinders. So first of all, I'm going to be modeling this cylinder, which is what's the radius? The radius of this cylinder is, so it's a smaller cylinder, so it's d6. So I'm going to be modeling this d6, and then the length comes from here to here. So instead of modeling just this one, then this one, it's usually easier to model this cylinder, and then now model this cylinder, and then model this ceramic. It's also a cylinder. So one thing I just thought about is that I would provide these values, these variable values. I would put it in the description. I'll put it in the description so that you can have the values yourself. I think I should think of how to a place to upload the files to, but if you have any suggestions, please let me know. Yes, so the first cylinder would be now, so the radius was d6 divided by 2 and the orientation y, and then y max is plus L5, so that's the highest point, and then the y min is L4. So we see that the way I drew this, it's you have that this is L4 and this is L5, so that's the maximum y and then the minimum y. So and now I could preview. Okay, I really can't see it, so I'll just click OK and then check afterwards. So none to all, and then I'll just check it afterwards, so it's in the correct position. But then one thing I just noticed is that it has the wrong material. So I go to the solid, and go to assign material and color. So I change it from vacuum to perfect electric conductor. And when I click on it again, I see it reflected. Now to model the next cylinder, it's just the same thing repeated over and over again. Y outer radius is I think it's d what de, yeah, so that's de divided by 2, and y max is, okay, I think I would have to explain this. So the way I model this is such that it would be at the middle of so that the center of the cylinder would be at the middle of L5. So I'm going to be using L5 over 2 at some point to position the center. Then I would offset it both positive and negative. I wish I could type it. Okay, I think I can. Notepad. Yes. So first of all, I'm going to be positioning my center point at this point. So it's going to be whatsoever. Okay, let's assume that I have the length from the bottom to L4. So I'm going to have it as big L. Then what I'm going to do is I'm going to do plus L5 divided by 2. So that moves my length, my height or length whatsoever, up to the middle. Now to get the top and bottom point of the cylinder, I just have to add and subtract. So for the top point, that's y max would be equal to this, then plus, now what's the length of the cylinder itself? It's LE, so plus LE divided by 2, and then just go ahead and copy this, and then y min would be L5 minus LE over 2. So this is how I do my calculation. So I'm going to be using, I think, this a lot to position the components. And yes, now I lost the y's that I copied initially. I'm not going to type them again, so I'm just going to put ri as a placeholder. I'll come back to change this. So if I preview, you see that it's not, but I don't want to have to type the dimension all over again. So I'm just going to OK, and then go back to my previous solid and double click and then copy the maximum, and then, because it's a pain to type these variables all the time, so I'm just going to change that. So it's L5 over 2, which centers it, and then plus LE divided by 2, and then I can go ahead and copy this, and then this is minus LE over 2. Yes, then preview. Yes, so you have it positioned correctly. I mean, you could also make your model such that it has a different relationship, but then I just found it simpler to have it at the middle of L5. You could also have a different variable to show the offset from the bottom point, and yeah, have more control, but then maybe you have more variables. So now I copy this variable arithmetic again and OK. Now I have this. Now the next is to model the ceramic, which is this yellow stuff. So the thickness is which is the height, which is tc. So it's going to be exactly the same thing with this other, I think I could zoom it, Oh boy, I think I did something. No. Yes, so it's going to be the same with this cylinder, but then it's going to be plus and minus TC divided by 2 because this is also a model such that it is at the center of this cylinder. So what I have is, oh, come on, new, escape, and then the thickness is not thickness, the radius is d5 divided by 2. d5 divided by 2. I mean, you could also use radius to work. So instead of having these, you have r's. I think I found it easier using d for the scratch diagram. Then orientation y, and then y max. So instead of le over 2, you have tc divided by 2, and then you have a minus tc divided by 2. Yes, and I can preview. Now I have to change the material to ceramic, so I'm going to load material from library, and once you click on it, you have this material list, but then you can also go to the search and just type out ceramic, so you have ceramic and then load. So the ceramic is loaded now. I don't know if it's available in all CSC versions. I think it should, but then this shows that maybe I saved it a while ago, so I'll just show the properties in case you don't have CST on your, that's what, in case you don't have ceramic, sorry, on your CST. I'll just show the properties briefly. So preview, and there you have it, and okay. Now I'm going to be doing this twice, and the reason is because I have to subtract it. I'm going to be modeling the ceramic cylinders twice because I have to subtract it. Now yeah, okay, before I mention this, I'll show the properties of the ceramic in case you do not have it. So you go to materials, and then hook coupler. I mean, it wouldn't be in, if you don't have it, then you wouldn't have this, so you can just create a new material. I'll also show you how to create a new material. So these are the default properties of the material. So the only thing that is different is epsilon, so which is a value of 10. I don't think there's anything different in conductivity and mechanics. No, this is the only difference. So you change it from 1. For default materials it's 1, so you can change it from 1 to 10. So how to create a new material? You could just go to right click on materials and then create a new material, and voila, that's it. So you just change this to 10, type normal, and then you can change the color to yellow if you want it to match my my own model. So, and then leave the rest and you okay. So you could also save the name to ceramic instead of material 1. So, and then material folder, you could create a new folder. You could just, I think you could leave it. So that's it, how to create a material. So the properties is 10, and then maybe color yellow, and then ceramic, and then okay. Yes, I don't know if I should click OK, whether it saves. Yes, I click on OK. Yes, so I have a new material here, and then you could add this to add it to material library so that when you open another file, you already can access it from the material library. I think that's what I did for this ceramic, but yeah, I think I can just delete this now. Delete. So I mentioned that I would have to model this ceramic twice, so I can subtract it from this. Now I prefer this to copy, because one thing you could also do is, because it's exactly the same stuff, you could also copy and paste. You could also copy and paste the cylinder, but then I think I ran into some issues when I tried to back update. So if I wanted to go back in my history list and update something, I think I always had a problem with this, with copying. So I just I mean, ever since I had some issues with copying and updating the history, I always just model a second ceramic cylinder, and then cut it from this chamber vacuum. So that's what I'm going to do. And cylinder, escape, and then the radius is d5 divided by 2, and yes, y max is yes, and then this is So minus tc over 2, so exactly the same thing, and then plus tc over 2. So preview is going to be at the same place, so you could change it or leave it, but I'll just leave it. So okay, and none to all. Now what I want to do, I have solid 6 and solid 7 exactly the same thing. Now I want to subtract this from this. So yeah, what I have is I click on solid 3, and then I go to boolean, click on the arrow at the bottom, and then go to subtract, and then what it says is select the object to subtract from, and you click solid 7, and then when I press enter, I have it subtracted. So currently what I have is just the oh, I think I made a mistake. I have just the beam pipe, but then it's subtracted. But one mistake I made is that the yeah, the ceramic is actually not a full cylindrical disc. It has it's a hollow cylinder. Yeah, I think that's what you call it. So the inner radius, which is what we have here, the inner radius would be DE divided by 2. So that's the inner radius. So I'm going to update that now. So DE divided by 2. And yes, preview, and okay, I hope that's correct. So if you should, oh, I think there's a problem. So solid 5, is it solid 5 or solid 6? Oh, sorry, I think I edited the wrong solid. So this is supposed to be 0. Yeah, this is, yes, close. So the ceramic is actually solid 6. So this is DE divided by 2, and preview, yes. So this is what I have, and then now I've already subtracted solid 7, which was also the ceramic, from this, but then it is still saved somewhere in, I subtracted it from solid 3, so I could double click on solid 3, and then I can access solid 7, which is clicking this and then double click, so I can update this also to DE divided by 2, and yes, and then so it updates everything. So what you have now is solid 3 being this kind of shape, and yes, so that's it, we have that. And now moving down, I want to model this part, and then, oh well, this is going to be really long, but brace yourselves. Now for the next cylinder, the radius, as I can see here, is, okay, I'll move it here. The radius is D4, so the radius is D4, yes, D4. Diameter is D4, then radius is D4 over 2, so this and escape. So orientation Y, D4 divided by 2, exactly the same thing we did before. And change the material to PEC, which is your perfect electric conductor, and then yes. Now the maximum Y max is at L4, and then Y min is of course minus L4, so your Y min only gets up to L. Did I add C34? Oh damn, I think I missed C34 in my addition of the length, so I'll go back to all the other cylinders I've drawn and then include it. But after this, so it goes from the max is to L4, and then the min is without L4, so I'll just update it. So I have L5, L4 plus L5, but then I'm supposed to have C3, I'm supposed to have C34 before, so C34 here, and yes, so up to L4, and then the minimum would just be minus L4, which would be without L4, so I will just remove the L4, and then I can preview. I have my solid, but then because of C34, you see it's kind of sticking up, but that will be fixed in a jiffy by going back to all the solids and updating it. So yes, that's it. So I go back to my solid 2 and just add because your C34 is between L3 and L4, so I'll just add it there, and yes, plus C34, Okay, and I'll add it to this. Oh, then I have to add it to the ceramic also, so I'll just go plus C34, and maybe I'll just copy it and plus C34, preview, it moves up. Okay, and then I would have to do the same for the cylinder, plus C34 plus C34. Yes, and I think I already defined for this. Yes. Okay, now over to the next solid. This is plus C34 and plus C34, and then go to the next. Plus C34. Yes. Oh, and the last one. So it's quite easy, like going back to the history list and then updating the variables if you made any errors. So everything is back to normal. No, there's one solid missing. Oh dear, I didn't save the last solid I modeled. Okay, so we do it again. But before that, I copy this. And how come that did not save? I should have solid 7 or 8 already. That's odd. But yeah, no big deal. I go to model, and I also, it was D4, if I remember. Yes, D4 divided by 2 pec, and y max is to L4, and y min is without L4, so C34 is there. Yes, we have it again. And okay, then the next one I want to model is this cap. So I think I give it a thickness of 5 millimeters. That's just random, but I don't think it's part of the variables here, but it's 5 millimeters. So the thickness of this cap is 5 millimeters, and it's also a cylinder. So the y min would have to be the current minimum also, and then just offset upward by 5 millimeters. So I'm going to go to this and then escape, and orientation y, then the radius is d34 divided by 2, and then y max would be I think I have to update the copy. So the y minimum is y4, then the y max would be plus 5. I just used 5 millimeters, so I could preview. Okay, without the L4, so preview. Yes, so that's what I have, and I click on OK. So I always go back clicking the last solid so I can see what I'm doing in a preview, because if automatically once you press the enter, it selects the whole the whole model again, and then you can't really see in preview if you should try to create something. Now for the next, we have that the y maximum is L3, and then the y minimum is okay. First of all, I would like to model this L3 cylinder here, so this small one. I'd like to model this cylinder first, so this one, and then I would put the cap and then put this also. So let's see. You could try and follow the dimensioning yourself. So the radius of this is what's the radius of this? I think this is also so what will be D3? Well, I guess I made it the same as D1. So I think I made the diameter of this to be the same as the diameter of this, so D1. Okay, yes. D1 divided by 2, and or I could just make it D3 and make it equal to D1 divided by D1. I think I could. So I'll make it D3 and divided by 2, and Y maximum would be without the C 3 4, and then Y minimum would be without the L3. Yes. So this is, then they're asking for D3, so I'll just make it D1 for now. Yes. So this is what we have, and I can click on okay. Yes. Okay, had to do something. Hopefully the video did not stop. Well, 40 minutes already. This is long. Okay, then I think I'll maybe pick up the pace a bit. Then I'll go to model the cap, and that's cylinder, escape, orientation Y D34 divided by 2, and then Y max is this, and then Y min is, so Y max is with L3, and then Y min will be with L3 but minus 5. Yes, so that's what we have, and that's what I want. So okay, and click on 10. So the next thing is to model this notcher, which is also a cylinder. Okay, you can't really see it from here, but then it's a cylinder also, but then orientation is in the Z. So, and then it goes from the center to the edge, so it goes from the center to DCH over 2, which is yeah, DCH is the radius of the big cylinder, and this goes from 0 to that DCH over 2. I keep using radius and diameters interchangeably, and it is positioned at the middle of this rod, which is L3. So I go to cylinder, escape, yeah, orientation Z if it's not already in Z, and then the outer radius, so I'm going to be making it D3 also, divided by 2, so the radius of the cylinder, and then the Z max would be DCH divided by 2, and then the Y center, so I'm going to have to shift it up, so the Y center would be plus L3 divided by 2, which centers it, and yes, so that's the Y center, so that's this. But then I want to make it I want to make this in the same orientation as I have in the diagram, so I'm going to use minus DC over 2. Yes, so I have this, and yeah, that's it. I mean, I could also move it to the bottom so that it has yeah, I think I'll just leave it here. So D3 divided by 2, and okay, yeah, okay. So click on this again, and yes, what's next? So this part, it's a bit tricky to model, and I think what I did was just to model a cylinder with the total length of this. Okay, because I have to separate it, so I would model the first cylinder to have a length of T23 plus C23, so at this top, and then model a bottom cylinder to have the length, still the same length, T23 plus C23. So that's what I did, because otherwise you could just model it as one big cylinder, then use some kind of cuboids to cut through it, but then I want to be able to separate the top antenna from the middle antenna from the bottom part of the coupler antenna. Yeah, so I'm going to do that separately, and then what I have is yes, cylinder, escape, and Y orientation, Y max, so the radius is D3. Yes, I might change D3 later, but, and then the minimum is this, so the maximum is without L3, and then the minimum is without T23 plus C23. I hope that is correct. D3 divided by 2. So that's for the top part of the cylinder. We're going to be cutting this, and we're going to be cutting this a bit later. So okay, and click on it, and then I want to create now the bottom cylinder, so which is, I'll create a bottom cylinder, which is this. Then I'm going to be cutting it with just two cuboids. Or I could already cut this top cylinder. Okay, now to cut the top cylinder, I'll just cut it so that I mean, you could do any of them in any order, but I want to cut this first so it already looks like. Now let's see, how do I cut it? So I want a a rectangle, which is what's it called here? I'll check later. I want a square, a rectangle, a cuboid, which is the dimension should be, okay, I think I missed a variable. Now this variable, the distance, the separation between these two is I called it G23, so G for gap. I think I should have it here, yes. So it's here G23, so I want the separation to be G23, so this distance here, but then there's a problem of this distance. Okay, I'm just going to make the thickness, so from this to this to be G23, and yeah, let's see if that's correct. Okay, yeah, G23, and then yes, the height of course would be T23 plus C23, and yeah, let's see. I mean, if I make a mistake, then I'm just going to try and correct it or look in my old model. So I go to break, escape, and so what I want is for the y to be from the y max to be, I'll just paste this and then paste this. So what do I need to remove from y max? I need to remove L3, and I leave T23 and this, so this I remove this, and the Z min and Z max, I mean, you could use anything because we are going to be subtracting it anyway, but I'll just use I'll use D3, which is the radius, divided by 2, and then minus D3 divided by 2. So because I want it to go both ways, and then X min and X max is I think I'm missing something. So Z, okay, Z would not be D3 over D2. Okay, because I want the gap, so looking at the reference, so I want the gap to be around, wait, coming. So I want the gap to be starting from here, and then I'm G23. I hope that's actually correct. I'll see. So what I have is Z plus, I want it to start from 0, or rather I go to D3 divided by 2, which places my midpoint here, and I want to shift. So this is Z minimum or Z maximum, this D3 divided by 2, and then I want my Z minimum to be shifted by G23, so G23. I don't think that's correct, but yeah, okay, minus, sorry, so minus G23, so this is what I have. And yes, my X min and X max, I'll just use that as D3 over 2 and minus D3 divided by 2. Preview. So I could take a look at the other side, and then I see that it would clearly subtract and everything. So, oh, now I made a mistake in the modeling, but I would fix that very soon. I'll fix that. So I'm going to just OK this for now. Now the mistake I made is that, as you can see, I always make this mistake. The orientation, it's really important. The orientation of the coupler is really important. So the orientation is kind of facing this beam pipe. So the beam pipe Z axis, so the plane, the XY plane of the beam pipe, that's what it's facing. But what I have here is that this is facing the YZ is on the YZ plane. So I need to change that. So I have to change the orientation because the cylinders are symmetric anyway. I don't need to have, make modifications, so that the only thing I need to modify is the direction that this is facing. So I'll go over to solid 11, and yes, so instead of so first of all I copy the Y center, because when I should change the orientation it shifts, so I want the orientation to be X instead of Z, so this shifts of course. And then I have minus dch divided by 2. Yes, so I mean you could also rotate it, but I think it's better just changing the model. Yes, so that fixes the first one. And then for the cut, now we are aligned in the proper, I don't know, you can't see the beam pipe, but it's there. Yeah, that's it, we're in the proper alignment. And yes, for this to cut it, so it's now in the, okay, minus G23. Yes, no, what do I have? X min and X max, no, this is not correct. Yes, it should be correct now, yes. But then I'm not sure about this, so I'm going to check my old model. I don't think it's, I've now forgotten what I did. I think I also ran into some problems with modeling it before. So I'm going to go to my old model and then go to the history. You could always access the history. And which solid would it be? I think, let's see, run to. Oh, it's going to delete my results. Okay, no problem. So where was I? The model here. I have just looking at the dimensions. So I have that, and I have, okay, I think I modeled all the solids before I did this subtraction. So I'll just go to this, and yes, so Boolean shapes. I want to see what I added and what I subtracted. Okay, so I think I subtracted, let's see, so solid 12. Oh, it's not positioned at the end. Okay, I'll just run it to this point. Yes, now so define break. So minus G23 divided by 2 X range. And okay, now I know what I did. Yeah, continue. So just close this. Now I know what I did. Yes, so I want this gap, the total length of this gap, to be G23. So what I do is I offset the top one from the central axis, from the central y-axis. I offset it G23 minus 2. Then on the other side I offset it G23 plus 2. Yes, that's what I did. Now I remember. So what I have here is define break, and so for the y I have this, and then for the x-axis I want it to go from the middle to minus G23 divided by 2. Okay, not from 0, but from D23 divided by 2. Yes, exactly. So I can cut this off. That took a whole lot of time. So I change this to minus, and then I could view it, yes, to make sure that it cuts everything. So I have my brick. Now I can subtract the brick from this cylinder, which is solid. Oh, okay, complaining. Solid 12. So I click on solid 12, and then I click on solid 12, and I go to Boolean subtract, and I click on solid 13, and voila, this is what I have. So if I'm viewing everything together, so I'm just holding control and viewing everything. So this is what I have, which is what I wanted. So I'll do exactly the same thing for this bottom part of it. So I'm going to model the cylinder first and then subtract the brick from it. Now cylinder, escape. Oh boy, I hope I copied that. So why? Oh, I have a different thing. So I'm going to cancel that and copy. Okay, my battery is low. So I'm going to, oh come on. Okay, yes. Now I want the cylinder. I need to copy this dimension, the Y max. And then I go to escape and orientation Y, outer radius. Yeah, it's still D1 divided by 2. Then Y max is this and this. So I just copy the variables and I want to remove. So I have to take out. So let's figure this out. So currently I have to this point, but then I want to take out C23 as the maximum and then take out T23 and C23 as the minimum. So for the first one I just take out C23 and then for the second one I take out everything. Yes, so if you could view this clearly, yes, so you have the space. So the space between here and here is also C23. I think that's that. Okay. Yes. And now for the other subtraction, so use a brick, escape, and yes, Y max and Y mean. So I remove this and take out this and Z mean minus D3 minus D1 divided by 2 and then D1 divided by 2. Or is it D2? Yeah, D1 is the same as D2. And X mean, that would be, now I want the minimum to be at this point, so minus D1 divided by 2 and then the maximum to be offset by G23 divided by 2. Hopefully that's right. Yes, so we got that. So in the end what you have is that the total distance between this point, which is from the previous cylinder we subtracted, and this point should be G23 total, because I have minus G23 over 2, half of G23 on one side and half of G23 on the other side. So yes, okay. And now can subtract. So click on solid 13, go to boolean, subtract, and then click on solid 14 and press enter. And voila, we have the second part. Whew, that was so easy. Okay, now back to modeling. So the next thing we want to do is let's model this part. So I have one cylinder oriented in the Y with length L23 and then one oriented in the X with length DCH over 2. Yes. So cylinder, escape, and Y, and I have I hope I still have my, yes, I still have my dimensions. So I'm going to copy a new dimension because now we're already done with this. So I'm just subtracting, I'm just removing as I'm going down, just removing from the dimension. So the maximum will be L23, but then the minimum would be minus L23. Improper radius, so the radius is D1 divided by 2. So yes, this is what we have, and I think that's it. Okay, then click on it so I could see. Escape, and the orientation is X. Now I want the Y center to be at the middle of L23, so L23 over 2, and then X minimum is 0, and then X maximum is DCH divided by 2. Hopefully that works. Improper radius D1 divided by 2. Okay, this is plus, so minus, and voila, that was easy. And what do we have next? Yes, so we're done with this. Now the next one is this curved part of it, and then we're going to be using curves to model these curves and splines. So this part is going to be a spline, and then this part is going to be a polygon. So I'm going to turn on the plane again, the working plane, just so I see what I'm doing. And yes, go to modeling and go to curves. And the first part is a spline. So I can just click on 3 random points to kind of give me an idea of the shape, or 4. I think it's 4 random points. So click on 4, then click on escape. And now I have this kind of spline. But then one thing you'd want to change is you have the knot mode, which is interpolate through and interpolate between. What we want is interpolate between these 4 points. Now I'm going to be getting the dimensions from this for these 4 points. Now the maximum would be, so the y coordinate of this first point. Now when you click on each of the points, you have the red points move with it. So the maximum, the y at this point would be this, yes, which is correct now. And then the x would be 0. And what I want to do is so I have the total length as L2. So I have the total length as L2, so I want to kind of apportion it. I always forget the ratio that I use. So I have L2, so I'm subtracting some parts of L2. I think I use 1.5 and 2.5. Let me see. 1.5 times, no, it can't be 1.5 times, because that would be more than L2. I think I'll just keep it like this and get the dimensions from my other model. There's a particular ratio. I mean, you could use L2 over 3. I think I could try using L2 over 3, and then okay, plus L2 over 3. That's 2. So this is L2, right? I want it to be 2 times L2 over 3. So preview. Yes, 2 times L2 over 3. I hope that's the ratio I use in the other ones. You could use other ratios, but I just found this one to kind of give a really smooth transition. So the next one would be L2 divided by 3. No, I don't think I use this. Okay, then this one will be without L2. Let me see the ratio. This one will be without L2. I think it looks good enough. Yeah, it does, but I'm not sure I used in my previous example if I used kind of 2/3 of L2. So I have 1, 2, 3. Yeah, I think it makes sense to divide it into a third. Or is it a fourth? I think 1/4 would make more sense, because okay, here would be 0, and then here would be a quarter plus a quarter is a half. No. Okay, a third makes sense, because here is 0, then a third, then 2/3, then the whole. Yes. So that makes sense. So a third and 2/3, so divided into equal parts. Yes. And then now for the x, now this is a bit tricky, because for the x we need to get the offset from the center to this point, which is not readily available. Yeah, there's really no way you can know it by just looking at it. So what happens is that I know the distance from the wall to this point, so I'm going to move first to the wall, which is I'm going to add dch divided by 2 and then keep subtracting till I get to this point. So it's going to be dch, which is the diameter of this point, divided by 2, so is the radius. So I'm going from here, the central axis, to this point, and then I'm subtracting ch, which gives me to this point, and then I'll subtract d1 divided by 2, which gives me to this point, and then when I subtract dh, I have this point, so which corresponds to the x we want. So I have what I just said, dch divided by 2 minus ch minus d1 divided by 2, then minus dh. I think that should be correct. Yes. So exactly the same thing, dch divided by 2 minus ch minus d1 divided by 2 minus dh. Yes, so there we have it. I mean, if there was any mistake, then we would always be able to come back to it. So then you click on OK. Now that gives you the first part. Now this is just a curve. We're going to loop a circular cross section over it. So next we want to model the lower part. So I just click on try to get a rough estimate of the shape. Let's look something. Oh, sorry, cancel. So what I want is not a line but a polygon. A line just lets me draw one line, but then I want a polygon. So I want to continue. So I just kind of roughly gauge it and kind of try to get the shape. And then once I'm done with the last point, I click on escape, and then I can now start filling in the value. So this would be -2. So I'll just copy out this again. So I've updated the copy, and then this would be DCH. Remember, minus this is painful to type. DCH divided by 2 minus CH minus D1 divided by 2, then minus DH. Yes. Oh no, minus DH, not minus CH. Yes. And yes, this is now the location of this other point would be the location of this point, which is here. I'm going to blend it so I get this curve. So I want the height from here to here, which is going to be L1. So I'm going to be removing L1 and DH over 2. So I'm going to be subtracting from the length I have. I'm going to be subtracting L1 plus DH over 2. So from this, I'm going to be removing L1 and I'm going to be removing DH over 2. So what I have left is just Ri minus P. So that's it. And then this is on the same axis. So Ri minus P. And then this location, the X location would be, so I need the location of this point, which will be DCH, which is gets me to this point, minus CH, then minus D1 over 2. So D1 over 2 is half the radius of this cylinder here. Half the diameter, not D1 over 2 is the radius, half the diameter, of course, every time. I always make that mistake. So this is going to be DCH divided by 2 minus CH minus D1 divided by 2 minus DH. And then this is going to be DCH divided by 2 minus CH minus D1 divided by 2. And then this is going to be the same. And then for the height of this is going to be whatever we have at this point, then plus DH over 2 to get here, and then plus LH. So this is going to be Ri minus P plus DH over 2 and plus LH. So there we have it. And okay, now the next thing to do is to blend it. So click on the polygon and click on curves, and then go to blend curve. So you want to blend this point, and then the radius would be DH over 2, which is the radius of the curve, DH over 2. Preview, and okay. And then we want another blend, which is blend curve, and then we want to blend this point. So this is DH over 2. Preview, and voila, we have a profile. Now to get the circular cross section that we have to sweep over, let's select this solid, no, not this solid, this solid, and then now I want to draw a circle over this face somehow. So we have to align our axis. So I'm going to click on F, which is to select face, and then I'm going to double click on this face. Now once I double click on the face, I want to align my axis with this so that you'd see also the working plane also rotate. So I want to align my axis with this. So we now have a new axis, which is UV and W. Then this is the global axis. So this is what we have. Now from here I could click on 8 to look at the top. Okay, no, that's not it. I think it's 3. Yes, to look at either the top or the bottom. 3 or 1, I think. No, not 1. 3 or 5. Yes, whatever, it's the same thing. So Now I want to draw a circle on this, so I go curves and circle, and then from the center, I just try to gauge it and I try to get this, but then I'm not going to leave it as 9, I'm going to make it parametric, so dh divided by 2, which is the radius, and then u center and v center 0. So that is preview. Dh over 2, no, not dh over 2, d1 over 2, sorry. Yes, okay. And now I can turn off my local axis. So you see local axis is highlighted here, so I can turn off my local axis by clicking it, so it returns me back to the global axis. And yeah, because the axis is annoying, working plane is annoying, I'm going to turn it off. So now I have two curves. Okay, one thing I didn't do was to move this to a different curve. I don't think it works. If you should, no, I don't think it's okay. I'll just try. But then I think from experience it doesn't work, but here it goes. So I want to go to modeling, and what I want to do is to sweep curve. So I already selected the curve, and it said double click to select profiles to sweep. So I've already clicked on this, and it is highlighted. So when it's not selected, it is ash, but then when you select it, it's blue. And then I should click enter, and then it asks me to, once I click enter, it changes to red. Now it asks me to select the path to sweep through, and that is this. So you see it's already highlighting it, so I double click, and then voila. Oh, it actually works without moving to a different curve. So yeah, that's cool. So I have my profile, and I just click OK. So voila, wow, I think we're done. Yes, so this is what we have. I think we've modeled everything. Yes, the antenna, the chamber, and everything. Yeah, we modeled everything. So that's it, and now we can start applying our Boolean operations. So I think I'll make a separate video to run the analysis. So 3, because this one is already way too long. So yes, now we can start adding and subtracting our shapes. So first of all, I need the chamber and the beam pipe to be one solid, so I go 1 2 3 and selecting all of them with control. So I select one, I could use shift and select multiple, or I could hold down control and then select. And then once I'm done, I either click on Boolean, because the default is addition, or I can also go here and then click on this, but then Boolean addition. So it's added everything to one solid, and yeah. So remember the extension that was here is no longer there because it combines everything. So I could rename this as chamber. And then the next, I want to add everything in the top. So I have this. Now the ceramic is a different solid, so I'm just going to add this, and this, and Boolean. So I'm going to call this top, coupler top, or just put top. And then I'm going to rename solid 6 to ceramic. And then the other ones, I think they all go down to the bottom. So solid is solid 11. Oh, so Boolean, and then this would be the mid, and then the bottom 1 2 3 4. Yes, so this is the bottom part. So I click on Boolean, and then I save, and voila, we have a coupler. But then some other housekeeping that we might need to do is kind of round off the sharp areas. So for this, I created two variables, so blend and big blend, which is bblend. So for the chamber body, I use big blend, and then for the antenna, I use blend, which is small. So how to do that is so you have all the sharp corners. Not all the sharp corners. It's not all the sharp corners that you have to round off, but these ones. So to do that, you either go to curves, and no, not curves, peaks. You either go to peaks, and then you pick edge, or you could just click E, which is the shortcut. So I'm going to pick edge, and then I'm going to pick one edge, and then I click on E again. I pick this other edge, and then I click on E. So these are the three edges I mostly round off, and so I click on blend, and the radius is bblend, and I preview. This is what I have. I could also view this one at the top. So this is what I have. A nice. I don't think I do I blend this place. No, I don't think I blend this one. So I could just click on E. Okay, doesn't work. So I'm going to click on E and deselect one of these parts. I don't think I blend that. Let me see. No, I don't. Yeah, I don't. So I just blend the really sharp corners. So blend and blend, preview. Okay, and then for the coupler itself, I could go to the bottom. Let me start the bottom 6, 3. So I mostly use the numeric keys to kind of change the view. So either 3 or 6 or 0 or whatever, you get used to it. So I want to blend these corners. So all of this. So I'm just going to click on E. And yes, that's it. So blend, and I'm going to use small blend. And small blend is 1 millimeter, and then the big blend I think is 2.5 millimeters. Let me see. Yeah, okay, 0.515 millimeters. So preview. Yep. Yes. And yeah, for the mid, the same thing. Edge, edge, edge. And blend. Yes. And then I blend the caps also. So for the cap, I go to edge. I could have just selected them. Then blend, preview. Okay. And then for the top, I just have to blend the cap and some other things. So edge. Click on E. I think I also blend this. And yes. Oh, I think I clicked on P. Okay, so that's that, and blend. Yes, and voila, that's high order mode coupler. And then when you simulate this, you'd see the double notch. I think I'll yeah, do that in the next video so that this doesn't get I mean, it's already very long, so I don't want it to get any longer. So that's it, a full parametric model of a double notch hook coupler. I guess I could select this. Yes, so you see everything. And yes, that's all for this tutorial.